Hi.
Hi, Adam.
Can you play with me?
Sure, what do you want to play?
X and O's.
Okay, you start.
Bink.
Okay, my turn.
Whoop. Bink.
Over the last few years, we have been designing Groupware for desktop conferencing, where two or more distance-separated people work on a shared task in real time. The first system we built was called Share. Share allowed participants of a distributed meeting to share a single-user application, such as the Emacs text editor. Group interaction was mediated by a variety of floor control mechanisms that best fit the particular style of the meeting. We then built several Groupware equivalents of paint and structure drawing programs. GroupSketch was a minimalist bitmap sketchpad. All users saw exactly the same things on their display. XGroupSketch was a second-generation version of GroupSketch. Its functionality included features such as color and line thicknesses, multiple fonts, and scroll bars for relaxing the "what you see is what I see" principle. GroupDraw was a prototype structured drawing application where participants could manipulate a variety of objects on the display, such as lines and rectangles. But building Groupware was a frustrating experience. It took quite a while to implement even the simplest systems, as much time was spent reinventing similar ideas over and over again. We decided to build a Groupware toolkit for implementing desktop conferencing. We believe this toolkit would make building Groupware only slightly harder than building conventional applications. To achieve this goal, we would have the toolkit provide a runtime infrastructure for managing communications and processes, a simple set of Groupware programming constructs, a stable of Groupware widgets that address the needs of conference participants, and primitives for constructing registration interfaces that let people create and manage meetings. The result is GroupKit. Our first scene illustrates what a user of Groupware built in GroupKit may see. First, the user creates a registration manager. Through this, she can monitor the conferences in progress and see who is in them. She can also join one of them, which in this case causes a multi-user sketchpad to appear on the display. This sketchpad provides multiple cursors and allows simultaneous drawing. Users can join other types of conference applications, such as a shared file viewer. This file viewer lets users view different parts of the file. The multi-user scroll bar widget on the right provides a person with a peripheral awareness of other participants' location in the file. The registration manager and applications that you just saw are all examples of what a programmer can design and build in GroupKit. The next scene illustrates how GroupKit's runtime infrastructure makes this work. First, every community of collaborators knows the address of a well-known workstation that is running a centralized registrar daemon. The registrar is simply a connection point that keeps lists of conferences, their participants, and internal addresses for managing communication. Next, a user creates a replicated registrar client on their workstation, which connects to the registrar. This client sets a policy plus look and feel for how users create, join, and monitor conferences. Other users have their own copies of a registrar client. Through the client, a user creates a conference application. Participants see this listed in their own client and can join to it. Other conference applications are started in exactly the same way. Let's now take a closer look at how GroupKit applications are constructed. We'll use an extremely simple example called Hello World. This particular application contains 3 participants. When any participant presses the Hello World button, the button's label on all screens are changed to indicate who is saying hello. Internally, most of the Hello World program just constructs the look and feel of the interface. The difference is that when a participant presses the button, the program gets GroupKit to multicast its attached callback as a remote procedure call to all participants. All replicated copies of the application respond to the request to change the label. The best part is that the entire Hello World program is only 11 lines long. Only a few words of this program, shown in the bolded boxes, are needed to make it group aware. The next example shows how GroupKit applications handle special conferencing events, such as a late entrant and arrivals and departures of participants. Here we see a user joining a GroupSketch session that is already in progress. Notice that the current contents of the shared drawing appear on the screen of the late entrant. Here is how this happens. When the late entrant joins the conference, the interface to the sketchpad is created. Underneath, GroupKit sends an event to one of the running replicated processes, notifying it that a late entrant needs updating. Using an application-specific callback, the process sends back a copy of the drawing and the late entrant is brought up to date. GroupKit also provides programmers with a variety of Groupware widgets that are easily attached to applications. This widget gives a user a dynamic list of who is in a conference. When a person is selected, information about that person is displayed, in this case, some information for debugging. Another kind of widget is multiple cursors that show how others are gesturing and manipulating the shared display. These are added to interface objects with only a few lines of code. GroupKit has two widgets supporting peripheral awareness and relaxed what you see is what I see displays. Multi-user scroll bars show where others are looking in a document. When participants align their views, they know that they are looking at the same thing. Another peripheral awareness widget is the Gestalt Viewer, which shows a miniature of a document on the right and overlays the viewports of participants as colored boxes. By grabbing a viewport, a person can scroll the master document. GroupKit programmers build not only applications, but registration interfaces as well. We have already seen the open registration system, which implements a free-for-all policy of creating and joining conferences. This second example shows a rooms-based metaphor for managing conferences. The idea here is that rooms contain sets of useful Groupware applications, similar to the way breakout rooms are used. Users can create rooms, enter them, and stock them with applications. When any participant enters the room, they are added to the list of people in that room and join all of its running applications. Another registrar client is the facilitated meeting control, where a facilitator decides who is in the conference and what applications they can join. On this screen, the facilitator selectively joins the participants in a brainstorming and sketchpad session. This creates the applications on the screens of the participants. The facilitator also has the power to remove people from the conference. With GroupKit, we are achieving many of our goals. We have said that the idea behind the toolkit is that it should be only slightly harder to build Groupware than to build conventional systems. We can measure this by looking at the scope and complexity of a variety of example applications built in GroupKit. A relaxed what you see is what I see file viewer with multi-user scroll bars and file loading facilities is only 45 lines of code. This brainstorming tool contains multi-user scroll bars and the ability to save, restore, and clear ideas. It is 74 lines long. Text chat, which lets participants hold a text-based real-time conference, is 138 lines long. This 133-line Tetrominoes game was created in only 2 days by a student at the University of Calgary. This game supports movement, rotation, and flipping of objects on the game board. The student had no prior knowledge of GroupKit or the Tickle language. TK Solitaire is a public domain single-user solitaire game. A student at the University of Toronto had to make only minor changes to 22 lines to make it partially group-aware. This post-it note editor lets a person create a note and selectively post it to other participants and even to oneself as a reminder. It was written in a few hours and is 121 lines long. The tic-tac-toe game, modeled after one built by the creators of the Rendezvous toolkit, supports different roles of the players. It is 116 lines long. This other version of tic-tac-toe, which is slightly longer, was written at Aston University. GroupSketch and XGroupSketch originally took 3 months each to write and debug their 5,000 lines of code. Re-implementing them in GroupKit took a day and is 322 lines of code. Complexity decreased more than 1 order of magnitude. If you would like to try GroupKit, you can get it via anonymous FTP at the following address. A Mosaic page will also give you information on GroupKit and the other projects done by our group.